Hi, and welcome back to Pacing Equilibrium in the First Price Auction Markets. This is part 3. In this video, we will continue to see how the results from this paper could be derived. And in this part, we're actually going to do all this technical part of deriving the dual of Eisenberg-Gale convex program. And from it, we will get all the properties that we want to have according to the definition of pacing equilibrium. So right here, I just wrote this Eisenberg-Gale convex program again. This time, I just flipped the signs in the objective function. So now we have the minus here and the plus here. And so we are, what we are doing here, we are minimizing now the sum of logarithms of agents' utilities weighted by the budgets. This is the utilities, this is the budgets. And this thing is, as we will see a little bit later, this thing will be interpreted as the remaining budget for agent I. Then we have the constraints for this problem. And the constraint, the first constraint is the constraint that expresses this idea of agents being utility maximizers. So the utility of agent I is the sum of the value that it gets from participating in this auction, plus the remaining part of his budget times the minimum rate, minimum ROAS. And this one here, as I already explained above, is because the agent values his budget at this is the minimum rate. So he cannot convert, he would not want to convert his budget to value if the conversion rate is less than this ROAS. Okay, so next thing is no overselling constraint. This is no overselling. Every item J, the sum of allocations of item J among agents should not exceed 1. Also, something that I actually missed in the previous video, we also need this condition that the allocations are positive or non-negative. And finally, that this variable that will be interpreted later as the remaining budget, this one should also remain positive. So now what we want to do, we actually want to derive the dual program. And for the reference how to do it, the best reference is the course from Stephen Boyd, which is called EE 364A on YouTube. And I think the most relevant is lecture 9. So there are a set of rules how we derive the dual. And to do that, we first need to introduce, first of all, we need to rearrange this into like the standard form for convex optimization. This is why I actually decided to change this one to minimization. And also we also need to convert all of the constraints. So the constraints looks like function less than equals to 0. So this is pretty obvious here. This is pretty obvious here. This one will have the sign added here. And this one also. And we will need to assign Lagrange multipliers. So the Lagrange multiplier for the first constraint will be called beta I, which is not a coincidence. This is the beta I, which is the pacing multiplier. Pacing multiplier. The dual variable or the Lagrange multiplier for no overselling constraint is the price, Pj. And then we would need two auxiliary Lagrange multipliers that will eventually cancel themselves out. We will call this one lambda ij for the non-negativity of the allocation, and ti for the non-negativity of this delta I. And we should also remember that all of these things should be greater than 0. This is like the dual constraints being greater than 0. All of these Lagrange multipliers are positive. So now we can write the Lagrangian. Let's try to do this. Lagrangian would be the objective function sum over I. This is sum over I log ui plus delta I. This is in the brackets. Now plus we take this move everything to the left hand side, so we have the sum over I beta I, and inside here we have everything moved to the left side. So this is sum over j xij vij minus delta I ri. Okay, the next one. For the next one, we will need to move to this side. So we have the plus, or we can have, okay, we have, no, actually we should, I'm sorry, we should actually move to this side. So we have plus pj sum over all j's. And here we have sum of xij's over agents minus 1 times. Okay, and here we have minus sum over I and j lambda ij xij. And finally, we have minus sum over items ti's delta i's for this one. Okay, so this is the Lagrangian. What we should add to the Lagrangian is we have this is the optimality conditions. The optimality conditions, or also known as KKT conditions. So what are those? First is that the first order optimality conditions using the primal variables. So this is saying that the derivative of L over xij, each of them should be 0, and derivative of L over delta I. So remember this was the this and this should be considered the primal variables. Also ui is also considered a primal variable. We could have substituted here, but it's a little bit easier to do it like this. So we don't actually need to do the derivative over xij's. We will do the derivative over ui. So I will fix this. Actually, we will need the derivative over ui. This is equals to 0. Then we have all the primal, all the dual conditions. And the dual conditions is that beta I is larger than 0, pj is larger than 0, lambda ij is larger than 0 and ti larger than 0. And we have complementary slackness conditions. What are those? Those are basically saying that we should multiply the Lagrange multiplier by the value of the constraint, which is less than 0, and this should be 0. So it's basically saying that beta I times ui minus sum over jxij vij minus delta I ri should be equals to 0. So it's either this one equals to 0 or this one. The same thing goes for prices. So pj sum over xij minus 1 over I equals to 0. So this is already something useful. This is saying that either this is 0, meaning that the object is sold completely, or pj equal to 0. So if there is somebody who wants to buy this object, the price will be non-zero and the object will be sold completely. Otherwise, the price of it will be 0. Let's continue with complementary slackness conditions. The next one is saying that lambda ij times xij equals to 0. This will be very useful. And finally, we have ti times delta I equals to 0. Okay. So what we can do next, we should actually start with we should actually start with this one. So let's take the derivative of this one. Let's see how it goes. So we have delta I here, and we also have delta I here, and we also have delta I here. So if we take the derivative, what should we get? We will get from here, we will get that dl over d delta I equals to -1. This is the -1 plus this is going to be ri and beta I, and there's also a minus sign here, so we should say minus ri beta I. And finally, we have the ti from here, minus ti, and this equals to 0. This is ri. Okay. And also remember this one, the KKT condition. So we can use it here. We could say that ti is equals to 1 minus ri beta I, and we also know that delta I times ti equals to 0. So we can say that delta I times 1 minus ri beta I equals to 0. And from here, we actually get an important thing. Remember, this thing is to be interpreted as the remaining budget, which is going to happen a little bit later. Remaining budget. And this thing says that either remaining budget is 0. In this case, if delta I equals to 0, then it follows that. Okay. in this case, only in this case, beta I could be less than 1 over Ri. But if delta I is actually larger than 0, then it would require that beta I exactly equals to 1 over Ri. And so if we scroll up back, we will remember that this was the second condition of the equilibrium. The no unnecessary pacing condition. Okay, good. So now we can actually see that if we substitute this thing back, like if we substitute this condition back here, this will eliminate something, like this will eliminate this term and this term and this term. It's just, you know, collecting all the things that comes with delta I and eliminating it. Okay. There's a problem. Oh, okay. So this is not correct. The minus sign only belongs to the first one. So we need to fix it a little bit. I'm sorry. Let's fix this. So this is like this, and also there is a sum over I. So this is actually a plus. Okay, so now it works. Okay. So now let's proceed with the second one. Okay, I will choose a different color. Let's see what should we do about this one. So when we take the derivative of Lagrangian with respect to ui, here is ui here, and this is the second time it appears. So we could see that this is going to be, it follows that this is going to be minus mi over ui plus beta I equals to 0. Yeah. So from here, we can actually see, okay, I will move to the bottom. Okay, so now we have bi equals to mi over ui, and this gives us the interpretation of beta I as inverse rows, because we are basically saying that this is the utility that we get, and this is the budget that we spend. And for the case where we spend the full budget, this is going to be something that we've seen here, that if we spend the full budget, yeah, if we spend the full budget, the delta I would be 0, and this will be the money that we spend, and this is the utility that we get. So this gives us the interpretation of the beta I as the inverse rows. All right. Finally, we need to, okay, we actually need to do the derivative of L with respect to xij. So let's do that. dl over dxij. What is going on here? So we have xij here, we have xij here, and we have xij here. So it's going to be minus beta I vij plus pj from here in minus lambda ij. And this is equal to 0. But also remember that by the complementary slackness condition, this one, by this condition, it's either xij equals to 0 or lambda ij equals to 0, and also the primal condition, this one, that lambda ij is larger than 0. So first of all, we can see that lambda ij equals to pj minus bi vij. This is larger than 0. So we get that the pj minus is actually greater than bi vij. So remember this one. This is the first price auction condition. Okay. This is good. Yeah. So if we substitute this one back, if we substitute this thing back, what will happen? Again, this is linear, so we will get rid of this one, and this one. So now we actually can substitute everything back and arrive at the dual. So what should we do? We should just say that now we eliminated all of the primal variables, and what remains in the Lagrangian gives us the dual. So the dual depends on PJs and BIs, and let's see what remains there. So we have UIs, and we can use this thing here. So we have minus sum over mi's logarithm. This should be ui. So this is mi divided by bi. This is this term. What else remains? I think the only thing that actually remains here is, let's use this one. This one, the sum of the PJs. Okay, and we also have this one, but again, by this condition, we can replace this one with, this is going to be mi. This is going to be the sum of all prices with a minus sign, and ui will be replaced by mi over beta I. Okay, so I think now it's good. We have this, we have plus sum over mi's and minus sum over j pj. And now this is to be minimized. And to this, we also add the conditions that we found, which is pj greater than bi vij. And the other one is this one, bi less than equals of 1 over ri. So what remains here is just to rearrange a little bit. We can actually split this term, split the logarithm. So I will rewrite it a little bit. Okay, let's have another one. gpj bi equals to, now this comes with a minus sign, so this is the sum of over mi's logarithm beta i's minus sum of the pj's, and what remains is plus sum over mi 1 minus log mi. Okay, and this is to be minimized, so yeah, I don't really like it. Why is it to be? Okay, so I'm sorry, this is to be maximized, of course. This is to be maximized. This is to be maximized. Okay, now it's good. Now it's all good. So we can flip the signs. To make a minimization. So this is going to be, okay, I will write more careful here. So this is going to be minus, this is going to be minus j, and minus g, and the g will be a function of prices and the spacing multipliers, sum over pj's minus sum over mi's log beta i's. So this is the weighted sum of pacing multipliers for every bidder. And then there is this constant. Remember that I mentioned earlier that there is going to be a constant c that we will need to have to make sure that the primal value and the dual value actually are actually equal. So again, we will need to have to bring back all these conditions, vij and beta I 1 over ri. So this is the dual problem. So we have everything that we wanted, or almost everything. We have this first price auction condition. We have this interpretation of beta I as the raws. We have this condition for no overselling and market clearing, and we have this thing for no unnecessary pacing. So what remains is that we still need to show the interpretation for this delta. We need the interpretation for the delta, and let's see how we can come up with that one. Okay, so for that one, we will need to use okay, let me think about it. Okay, so we can actually use this one. Yeah, I get it. So we can actually use this one. So how do we use it? We could say the following, that we have the following. We have that dbi equals to mi over ui. So we can also say that bi times ui, this is equal to the budget. And because of the slackness, because of this condition, we would substitute here because it's just equals to 0. So we'll put it here, minus beta I ui minus sum x j v I j over j plus delta I r I. Okay, so this thing is 0, right? Okay, so now we can see that mi could also be seen as, okay, this should be minus. This should be minus, that the budget, this is the budget, it is actually should be equal to sum of xi vij plus beta I delta I ri. This is sum over j's. And the final step is here. Remember that this thing could only be non-zero if this thing equals 1 over r over I. So these things cancel. Or this thing cancel. So eventually we get the following. We get that this is the sum. Okay, something is missing here. This should have been, okay, this should have been PG. It's correct. Okay. So this should have been the beta I here too. Okay. Yeah. And now we also remember that Pj equals to beta I Vij whenever xij larger than 0. So we can actually replace this thing and this thing with Pj. Okay, so now we're good. Now we can see that mi is the sum of xij pj. So this is the payment or the ad spend, and plus delta I. So this actually gives us the interpretation that this thing is the excess of the budget. Okay, so I think now we got everything that we wanted. All the conditions for the equilibrium and all the interpretations of the variables.